Alright, so we want to determine the x and y coordinates of the centroid of the shaded area below. Now, we have a cubic function right here, and it's written down here, but I thought it was a little bit difficult to read, so I rewrote this equation. I said it's basically y equals y naught minus kx cubed, and then over here we have like a little linear equation right here. Now, there's a few ways to solving this. You can use the method of composite shapes to solve this. You can pretend that this is a whole shaded area right here if you don't exclude this invisible area right here. And then you can subtract the centroid of this triangle later. But I'm going to do the integration method alone. And by doing that, we need some ground rules first. So we need to know what is our y naught, what is our k value here, what is the slope of this line, what is even the equation of this guy right here. So there's a few things that we need to actually figure out first before we even go ahead and start doing our integration to finding the centroids here. So let's go ahead and figure out what this equation is. Let's fill it out really quick. So in order to figure out what y naught is, so y naught, we need to know what is y naught. Well, y naught is basically the y-intercept of our equation. So where does this equation or this curve intersect the y-axis? And we can see that clearly here. It intersects at 12 inches. So y naught is 12 inches. Okay. Now we need to know what k is. So to solve for k, we need to know what coordinate on our point is here. So we could say, well, this is 0, 12 over here. Or we could say this is, what is this coordinate right here? We can use this one too. Now this one, this coordinate right here at B, it's a little tricky, but thanks to this triangle right here, we can tell what this coordinate is. So this is a 3-4 triangle. So we know that this distance is 6 inches up here in the vertical direction. So that must have meant that we must have multiplied by 2 on this 3 right here. So we need to do the same on the bottom here. So if we multiply by 2, this distance across here should be 8 inches. Okay. So this coordinate is 8, 6. Okay. Let's go ahead and plug those values in. So I'm going to replace y with 6. And y naught, we already know is 12, so I'm replacing that. K, and then x cubed, so 8 cubed. Now if we go ahead and solve for k, it's basically just doing some algebra. So k is going to be, and if we rearrange these values, I had k, it's going to be 3 over 256. Now this is definitely a fraction that we do not like at all. So, but we're going to need it. It might get a little bit messy when we do our integration, but it will actually clear some things out. So we'll see some things being canceled out here. Okay, great. Now we've gotten this equation. So let's go ahead and actually put in our known variables now. So we know that y naught is 12, and we also know that k is 3 over 256. So 256, we'll put that here. All right, so that's our y equation, and I'll call this y2 because we're going to have another equation here, and I'll call that y1. Now, y1 is a linear equation, and what is the slope? We need to know what the slope of this guy is. Well, thanks to this triangle, we know that there's a rise of 3 over a run of 4. So that's our slope, actually. So it's going to be 3/4 x. And the y-intercept is 0, so plus 0. We'll just leave it as y1 equals 3/4 x. All right, so now that we have figured this out, I'm going to actually erase this k because I written k over here. Let's go ahead and figure out what our centroid is now. Now that we've gotten basically all of the ground rules down. So I'm going to make a cross section in this direction with respect to x. And it turns out when we make this cross section, we can make this cross section and it can apply for all of these rectangles from 0 to 8 because there's nothing changing here. We're not introduced like a new equation at like at 6 when x is 6. There's not like another equation over here that's going to interfere. So we can safely make a cross section in this direction from 0 to 8. And let's go ahead and figure out what is our x bar. So our x bar is going to be all the way up here, this distance. And our y bar is going to be this distance right here. All right, let's go ahead and write those down. So our y bar, no, let's do x bar first. Let's do x bar first. X bar is just going to be whatever x value we have. So like if we go along the x-axis here, we should just be at our centroid. So x bar is just x. So that's good. Now our y bar. Now this is the trickiest part, is figuring out y bar, because we see that there's an open space here, so we do have to exclude, or sorry, no, we don't exclude this. This is a distance, right? Our y bar is a distance up to the centroid. So this distance is going to be our distance up y1, which is basically this equation, plus half of this distance right here. It's half of this distance. Now, what is this distance? Well, this distance is our y2 minus y1. So y2 minus y1, and we're having that distance, right? Okay. Now, I'm going to rewrite our y1 equation right over here, because I'm going to go ahead and erase this one down here. So let's go ahead. We can simplify this. And I'm going to put this in terms of x, because we made our cross sections in terms of x, right? So let's go ahead and replace what we have known here into our in variables of x. So y1 is 3/4 x. So 3x, I'll put 3x over 4, plus y2 over 2. So y2 over 2 is 12 over 6, or sorry, 12 minus 3 over 256 x cubed minus y1, which is again 3/4 x, and this is all divided by 2. All right. Now let's go ahead and simplify this. So if we go ahead, we can combine like terms here with this 3/4 x and this negative 3/4 x divided by 2. So if we go ahead and simplify this, we should get that our x bar, or our y bar, is 3/8 x, combining those like terms, plus 6, 12 divided by 2, and then this guy divided by 2, so that's going to be negative 3 divided by 512 x cubed. Okay, now this is our y bar. I'll go ahead and box these for the time being. We'll refer to these in a short moment. So, and then x bar, I'll also box that as well. Now, the last thing we need to know is our dA. What is our dA? Well, dA, we go ahead, I'll erase this since we've already solved for y bar. Our dA is this. Remember, it's this distance, this height, times our thickness dx. So dA is this distance. We said it's y2 minus y1. So y2 minus y1, which is 12 minus 3x cubed over 256 minus y1, which is 3/4 x. So 3/4 x. So that's our distance times our thickness dx. Now, let's go ahead, like always, as I always do, I always go ahead and solve for my area, which is the integral of all of these dAs. So let's go ahead and take the integral, and our distance is going to be from, or our bounds rather, is going to be from 0 to 8, right? So let's go ahead and do this. So let's take the integral of this guy that we have here, our dA, and if we evaluate this, so if we go ahead do that, the integral of dA is going to be, I can go ahead and write this step, so 12x minus 3 over 1024 x4 minus 3/8 x squared. All right, and this is evaluated from 0 to 8. Now you can go ahead and evaluate this. I assume that you should know how to do these types of evaluations, and it should simply turn out to being that the area of this total thing is actually 60. So that's great. So I'm gonna leave this as our area. So our area is 60. Now let's go ahead and solve for our centroids. So xc is the integral. Now our x bar is what? It's just x. So our x right here times our dA, which is 12 minus this guy right here, 12 minus 3x, 12 minus 3x cubed over 256 minus 3x over 4 times dx, and from 0 to 8 is our bounds. And to make this formula complete, we divide it by the integral of our dA. All right, so let's go ahead and evaluate this. If I FOIL this x in to all of these terms within the parentheses, and then I go ahead and integrate right here, we should get that the integral of this is 6x squared minus x to the 4th, or sorry, no, x to the 5th, x to the 5th times 3 over 1280 minus x cubed over 4, evaluated from 0 to 8 over our dA. Okay, so now that we have done this, let's go ahead and evaluate. So when we evaluate this, when we evaluate the numerator, our numerator is going to be, so let me actually do this really quick. So 8 squared times 6 is 384 in our numerator, minus, this should be, when we evaluate this term at 8, it's going to be 76.8. I'm just plugging these in the calculator and doing it. Minus 128 over the integral of dA, and we said that is over 60, right? Our integral of dA we found to be 60. And if we just go ahead and solve for this, our x-coordinate should be 2.99 inches. Nice. All right, let's go ahead and solve for our y-coordinate now. This is the last thing we need to do. So from 0 to 8 of our y-bar, and we said our y-bar is this big chunk right here, so 3/8x plus 6, 3/8x plus 6, minus 3 over 512, x cubed, times our dA, which is 12 minus 3x cubed over 56. So 12 minus 3x cubed over 56. I'm going to have to go back up and forth a little bit to refer to our dA. Over 256 minus 3/4 x times dx. And this is all over our total area. So now if we go ahead and FOIL this out here into all of our terms, it's going to be a long expression, but you can simplify like terms once you do all of that. And if we simplify that, we should be getting that the integral from 0 to 8, put a line right there, is going to be it's going to be this. If you simplify this correctly, it's negative 72 over 512 x cubed plus 9 over, now this is going to be a large number, 131,072 x to the 6th minus 9x squared over 32 plus 72. This is all multiplied by dx. The integral of dA on the bottom. All right, so now if we go ahead, we can evaluate this because we cannot simplify this anymore. And we get that the integral of this, if we go ahead and evaluate this, so it's going to be negative x to the 4th. Now 72 over, it's going to be 72 divided by 4, 18 over 512. Plus, now it's going to be 9x7 over 131,072 times 7. That's going to be another large number, even larger, because we multiplied it by 7. 917,504. And you would think that this simplifies with 9, but it actually does not. So it's going to be this large number right here. And we have x cubed. It's going to be 3 over 32 as our fraction, plus 72x from 0 to 8 over our total area, which is 60. Remember, we solved for that earlier. So I'll go ahead and put that right there. Now, go ahead. Now, this does seem intimidating. I know we have a lot of big numbers, but it's on the denominator. So when you go ahead and evaluate this, it shouldn't be too big of a number in the numerator. And if you go ahead and do that from 0 to 8, our numerator is going to be, actually, I did not evaluate this completely, but it's going to be 144 plus 8 to the 7th times 9 divided by 917,504. It's going to be 20. Is negative 144 because of this negative sign we have here. We have to carry that over. So it's negative 144 plus 20.57 minus 48. We evaluate this at 8 plus 576. And of course, if we evaluate this at 0, it's going to be 0. Divided by 60. Now let's go ahead and plug all of these in the calculator. So 20.57 minus 144 minus 48 plus 576 divided by 60. We get that our centroid in the y direction results to being 6.74 inches. All right, so there we have it. Now this did look like it took a lot of work. Now this will be my last video on the integration method for solving for centroids in this series. I wanted to make the last video of this series a little bit challenging. So here we did have two curves that were bounded in this. But the challenging thing is just finding the constituents of these two equations. That was the most challenging part. And then also finding what y bar was. That can also be kind of challenging. So let me go ahead and write this centroid. So remember, if we keep this in mind, our y coordinate was about 6.74. So that's a little bit over halfway. I'll just say it's about here. Nah, I'll say it's about here because if I kind of visualize this, it's kind of headlining at 6 right there. So 6.74, and I just erased that on accident. And our x bar, our x coordinate of the centroid is 2.99. Remember we said this is a distance 8. So 2 is 0.94, it's 2.99, it's close to 3. So I'll just say 3 is roughly around here. So if we go ahead and meet over here, this should be our centroid. So this is our centroid of coordinates 2.99. And you can go ahead and round that to 3 too, but I'm going to keep these in within 3 significant figures for the time being. And our y coordinate is 6.74 inches. So there you have it. If you have any questions, comments, concerns, compliments, go ahead and leave that down in the comments section below. And I'm going to go ahead and start centroids with composite shapes in the next series. So thank you for watching this series if you have been watching all of these videos, and I'll see you in another video.